Hello students, today we are going to solve a question from JEST 2021 and say part A question number 16 and say basically from that optics part, interference. So that question is given that you have a soft thin film having uniform thickness and the thickness of this thin film is given that T thickness equals to 5 on 0 nanometer. Okay. Also, it is given that the refractive index of this soft thin film is 1.33. Okay. In addition to this, it is provided that a white light is incident normally on this thin film, and the wavelength of this white light is given, that is ranging from 390 nanometer to 700 nanometer. So they have asked that what will be the dominated color of this thin film. So very simple question. You have a thin film of soft having uniform thickness of 5 on 0 nanometer. Refractive index of this film is 1.33. White light having wavelength 390 to 700 nanometer is incident on this thin film. So what will be the dominated color of this thin film? Okay. So very simple question. How will solve? So as you know that for constructive interference in thin film, the condition of constructive interference for thin film, that is twice mu t cosine of r, that will be either lambda by 2 or 3 lambda by 2 or 5 lambda by 2 and so on. And for normal incidence, that angle of refraction will be 0. So that condition will become twice mu t equals to lambda by 2, 3 lambda by 2, 5 lambda by 2 and so on. Okay. So I'll take this condition twice mu t equals to 5 by 2 lambda. Okay. I'll take this. I am not taking lambda by 2 or 3 lambda by 2. I'm taking 5 lambda by 2. The reason behind that I'll tell you after solving this. So from here I'll get that lambda corresponding to that dominated color of this thin film, that will be 4 mu t by 5. And we substitute these values now. So you will have 4 mu is 1.33 and t is 5 on 0 nanometer divided by 5, and that unit will be nanometer. Okay. So now if you solve it, if you calculate that wavelength of that dominated color of this thin film, that will become 540 nanometer. Okay. And that will be corresponding to a green light. Okay. So how I am taking that here 5 by 2 lambda. If you take that lambda by 2 here, then you will get that wavelength. You will not get this factor, reducing factor 5. You will get 4 into 1.33 into 5 on 0. And that values will not be in the range of visible light. That will be higher range. That may be in the infrared or something else. Okay. Also, if you take 3 by 2 lambda, again, you will get that wavelength corresponding to that dominated light will no longer be in the range of visible light. But when you will take 5 by 2 lambda, that wavelength corresponding to that dominated light will be 54 nanometer, that will be visible range. So we can see that light. Okay, we can see that light, and that thin film will be colorful, having green color of wavelength 540 nanometer. Okay, so that's why you have to take that the term corresponding to have wavelength, that will be lying in the visible range. So that may be lambda by 2, 3 lambda by 2, 5 by lambda by 2. You have to check it. Okay. Okay. Thank you.